Hello, happy Soul Season. My name is Chris Heaney, and I'm going to give you a quick demo of my Solana Hackathon project. So I've built a peer-to-peer binary option protocol, which is currently live on the DevNet, the Solana DevNet. And so a binary option is a option that pays out a fixed amount if the binary option's underlying assets price goes above or below a specified price on a specified date. So a Doge binary option will pay out $50 if the price of Doge goes above $1,000 on December 31st, and if it doesn't, it pays out nothing. I've created a protocol which enables two users to enter into a direct contract without needing to use an intermediary to do escrow or to basically confirm or disconfirm that the binary options condition is met or not met. I'm using the PIV network as an Oracle solution to provide the prices of the options underlying assets. And then I'm using Solana programs to handle escrow and bookkeeping and all that other stuff. With that being said, I can give you a quick rundown of how the GUI works and how you interact with the protocol. So on the main page, you can see the markets, the assets for which markets already exist, including the dates that the options expire, the conditions, and above or below, and the values that those markets exist for. If you don't see a market for an asset, condition, and value that you like, you can come in and create your own. You can basically make a binary option for any market that the PIV network currently provides prices for. I've already gone ahead and made a basically dummy market for BTC USD that expires today, that the price of BTC will be above $30,000. And for user number one, I've come in and basically had them make an offer that they'll pay 5 SOL to bet to win. They'll bet 5 SOL to win 5 SOL that yes, BTC will be above $30,000. Of course, right now that's fabulously true. It's trading at $34,000, but for the sake of the demo, it'll make it easier to demonstrate how settlement works. So now we also have a second user account here where if I go ahead and refresh the page, I'll be able to see the BTC, the same BTC market. And if they click on offers, they can see basically the other side of that first user's offer. So they could bet no, I'll bet 5 on no, BTC won't be above $30,000. So they can come in and take that offer. And upon taking that offer, clears it from the offer table, and now it shows up in the positions table. And so this poor trader's already lost a few SOL today, but I can go ahead and show that basically once a position is created, the user is going to see the opportunity to settle the market. And so they'll have an opportunity to settle the market if the day's current date is equal to or greater than the expiration date of the market. And since, of course, I made this market for June 7th today, we see the option to settle. So this user comes in and presses settle. And because they do that, basically they end up losing 5 SOL. And if we go back to the other account, refresh the page, and reconnect, we'll see that this other user, oh, come on. This other user will have made 5 SOL. So you might be wondering, why would that second user have basically settled the market even though they're going to lose money? I mean, it's a bit of a contrived example. But one nuance to the protocol is basically that the PIV network only stores the current price of assets. And what this means for our protocol is that we need users basically monitoring the state of prices and the markets that exist. And if they see any of the conditions for a market or a binary option become true, they need to send a transaction to the network that basically updates the binary option that says like, oh, this market's been settled and the outcome is yes or no. So a useful analogy for this is liquidators and compound, or the serum nodes that are basically making sure that the serum order book stays up to date. And to incentivize users to do this, if you do settle a market, you can basically be rewarded with a settler's fee, which is equal to 1% of all the basically all the SOL that enters escrow for a binary option. So you have the option here to basically withdraw it. Of course, if this was actually live, it wouldn't be people doing it from a GUI. There'd be bots that'd be monitoring this, etc. But for the sake of the demo and the hackathon, I've built it into the GUI. So yeah, that's roughly how the protocol works. I've included a link to the GUI on the GitHub README. So if you found this demo compelling enough, you can go around and play with it yourself. Thanks.